All right, well, I said the other day that this whole chapter is about right triangles, so let's do a little bit more with right triangles. This is something we've actually used before that you already know. I'm just going to go through it real quick, at least the first part. We'll call this side A and B. Those are the two legs of the right triangle. This right here, I don't think we've officially said what this side is right here, but let's officially say, what it is. This is opposite the right angle, so what do you think? You probably already know. Yeah, it's the hypotenuse, okay? When I was in college, we would get our picture taken, by the school photographer, for yearbook and stuff. And he'd always ask you what your major was. And I was a math major. And for some reason, every single year he took my picture. He'd say hypotenuse. And so every picture, I was saying hypotenuse in my picture. I just remember that. I don't know why. So that's what he would do. I guess he had different words for different majors, whatever major you're in. But a math major, he told us to say hypotenuse all the time. So there you go. I guess it makes you laugh or something. I don't know. So anyway, just thought I'd share that. So here we go. In the book, they actually use the geometric mean stuff that we were doing earlier. And it's kind of a proof of this theorem. If we had more time, I'd sit there and go through it for you. It is in the book if you want to see it. And if you're really, really interested, you can come to me some other time. We'll show you how we get the Pythagorean Theorem. Okay, it's a proof for the Pythagorean Theorem. So since I said that, let's write it down. Pythagorean Theorem. It's named after an old guy. Well, he's a dead guy now. I don't even know if he grew to be old or not. But anyway, he was a guy a long time ago. And what was his name? Was his name Pythagorean? What was his name? Anybody know? No? Nobody knows the guy's name? Pythagoras. Okay? It's named after the guy. He didn't actually come up with this theorem. He's the one that actually gave it a proof. He gave it a good formal proof, so they gave him the name Pythagorean Theorem. They knew about the Pythagorean Theorem before Pythagoras. Can you believe that? But I don't know what they called it. They just called it the right triangle theorem. Who knows? I have no idea. But it's called the Pythagorean Theorem. Here it is. I'm going to write it like this. Most of you guys are used to seeing a squared plus b squared equals c squared. Would you agree? What I'm going to do is I'm going to write it like this. I'm going to write it c squared equals a squared plus b squared. And there's a reason for that. There it is. That's the Pythagorean Theorem. All right, let's just chuck some numbers in here.
I thought it was a squared plus b squared.
Okay, I just got to... thank you, Emily. At least you're listening. At least somebody's listening.
I wasn't listening.
Yes, it's obvious. Okay, watch. Let's say this was, I don't know, I'll just make some numbers up. 3, and let's say that was 5. Okay, and let's solve for c. We've done this before. We've done it a bunch of times in the other chapter. So let's do it again. So watch. It's 3 squared. Actually, let's do it like this. Let's go c squared. C squared equals what? 3 squared plus 5 squared. Now notice, the c has to be the hypotenuse. Do you see it? So the the hypotenuse is always the one that's sitting there by itself. It's the two legs that are being squared and added up. All right? So don't add the hypotenuse squared plus one of the legs squared. That's not what we do. We take the two legs, we square them, we add them up, and it equals the c squared. So make sure that you do that correctly. So c squared equals what? 9 plus, whoops, I got ahead of myself, 25. So c squared equals 34. Do you see what we're going to use that square root stuff again? So we square root it. So c is, now does anything go into 34? Well, 2 does. 17 times 2. But can I take the square root of either one of those? No, so I have to keep it the square root of 34. So that's what it's equal to. Don't change it to a decimal. Just keep it the square root of 34. That's an exact answer. All right. Let me show you another thing real quick. So if you see something, if you have a triangle, okay, any triangle, c is always the longest side. And if I take c squared and it's equal to the other two sides squared and added up, what kind of triangle is that? It's a right triangle. Now let me show you something that you may not have seen before. This will be real quick. If c squared was greater than a squared plus b squared, okay, if I took the longest side, I gave you 3 sides of a triangle. It doesn't have to be a right triangle. 3 sides of any triangle. And if I took the longest side and squared it, and then I took the other 2 sides, squared those, added them up. If this one is longer than this one, I can actually tell what kind of triangle that I have. And that would be an obtuse triangle. So guess what? Think on your own. What if I took c squared and made it less than a squared plus b squared? That's right, it would be an acute triangle. Very good. Okay, so if I give you three sides, let's just make something up. Let's say 5, 7, and 9. Okay, let's go 5, 7, and 9 and see what kind of a triangle. First of all, can you make a triangle out of this? Remember we did this earlier?
Yeah.
You got to take the two smaller ones. The two smaller ones have to add up to be bigger than the third one, right? Is that true?
Yeah.
Yes, it is. Okay, so it is a triangle. Let's find out what kind of triangle it is. So what do? Take the two smaller sides. Actually, let's take the longest one first. Square it. Who's got a calculator? And then take this and take this. I'm not even going to put equals in between because I don't know yet. Give it a second. What's this? 81. What's 21 or 25 and 49? That's 60, 74, right? 74. So 81 is what? It's greater than 74. So what kind of triangle is this? It's an obtuse triangle. And that's all there is to it. Yes, I will. I'm going to have you put both piles, two different piles on my table up there before you leave. Let me write down your assignment, and then you can go. 72. No, that's a 9. 7 squared, right? So 546. Here's your page numbers. 546, 547, and we're doing 9 to 29. There it is. Okay, two piles up here. One for the worksheet, one for the homework.
On the table?
It's 8-2.
On the table?
Yes, on the table. Section 8-2. There it is.